So we know what is wave. I'm producing a wave from here to here. Okay, here I can also go back. So this is a wave. And wave, it seems that something is propagated from this direction to this direction. Okay, but what is actually propagated? If you look at the matter, the object here, it's not propagated. This one still oscillated in its original position. This one is still oscillated in its original position, right? So you can see every bar here is still at the same position, right? So the bar doesn't propagate. So for the wave, you see something is propagating. What is actually propagating here? How would like to say that?
Energy.
The matter doesn't propagate.
Energy in the form of a wave.
Energy is propagated, yes. Okay, because initially I oscillate this side. Finally, you can see the motion and this side. So the energy is propagated. So that's the important thing about the oscillation, about wave. Okay, the matter doesn't propagate. The energy does. Okay, and you can also see some other things. Another thing you can see is the pattern of the motion propagated. Okay, because I'm producing some oscillation here, and this pattern, the up and down oscillation, is propagated to that side. Okay, so a wave, you need to know that there's no real material is propagated by the wave, but the energy or the pattern of the motion is propagated by the wave. Okay. So if you use some simple words, you can say a wave. What is a wave? A wave is the motion of disturbance. Okay, so if I produce some disturbance like this, it's the motion of the disturbance. But please note that when we say the motion of disturbance here, we have two meanings. That means the motion of the energy, okay, the propagation of the energy, and the propagation of the pattern of the motion. Okay. Any wave will need medium. Okay? So this is the medium, some material, real material. You need some real material to propagate the wave. But the medium, the material itself, doesn't propagate. Okay. Okay, so that's something special about the wave motion. And we want to list the requirement of the mechanical wave. Here we started the mechanical wave. Usually you need three things. One, source of disturbance. Okay, you need to have some source to make the oscillation. Like here, I make the oscillation here, and it can propagate. Okay, so this is the source of those disturbance. Usually, it's some oscillation. Two, a medium. Okay, you need a medium to propagate the wave. And in fact, you need some medium which can sustain the propagation of the wave. What we mean it can sustain the propagation of the wave? In fact, it means there must, of course, it means it has to be connected. And there's the interaction, okay, between this one. So the oscillation of this one can make the second object in oscillation, makes the third object in oscillation, so it can propagate. So you need some connected object, some medium to propagate it. Okay. So if we want to emphasize this fact, we need to have some mechanism. Okay, the mechanism to relate the adjacent objects. Okay, here is a connecting force between these things. Okay, and that's why it's called the mechanical wave, because we have some mechanism in these devices. And by the way, we also want to say that on top of energy and the pattern, another important thing is also propagated. Momentum. Okay. So wave propagates pattern, energy, and momentum. Okay. And the momentum especially can be understood if you make this kind of wave. So it can propagate, it's harder for this one to do, but it can propagate the push to the side. So if you put your hand here, you can feel the pushing force. So it propagates the momentum here. And so you can see for the wave, it's quite spatial stuff. It can separate the mass or the real material with energy and the momentum. Previously, when we talk about the energy and the momentum, it's 1/2 kV squared or mv squared or mv. So they are related to the real material. They are the energy and the momentum for the real material. But in fact, we consider the wave. The energy and the momentum can be separated with the mass. Okay, this is very important in the quantum mechanics. So in the quantum mechanics, the fundamental object is wave, not the particle. Okay. So let's stop here.